All right, today's lesson is the second part of rational equations, and we're going to start on page 221. So turn to page 221. The warm-up is solve these mentally. So we want to figure out what x is. So x divided by 2 is equal to 3 divided by 4. What is x going to be? So if you think about like the relationship between the numerators and the denominators, you should be able to get an answer for these. Try it. All right, all of these are called two equal fractions, but two equal fractions is called a proportion. These are proportions. So you can see like, ooh, I'm going to double the denominator. So some number here has to be doubled to make 3. So to do it mentally, you would say x equals 1.5, 1.5. So if you double 1.5, you get 3. If you double that, you get that. Now, if you aren't like in the mental way, you solve proportions by cross multiplying. X times 4 is 4x. 2 times 3 is 6. So then you divide by 4 to get x by itself. X equals 6 over 4, which is 1.5. Mentally, you'd be like, this is divided by 3, so something has to be divided by 3 to get this. Well, that would be 18. So 18 divided by 3 takes me back to 6. 3 divided by 3 takes me back to 1. If you're a proportion kind of person, you would multiply. 1 times x is just x, and 3 times 6 is 18. So that's kind of almost a mental way to do it too. Then there's going to be two answers for this. If 1 is equal to 1, then those are the same, but there's two answers because you can square 2 or you could square negative 2 to get 4. So there's two answers to this one. This one's also the same. X times x is x squared is equal to 16. There's two answers for that. X is equal to 4 or x is equal to negative 4. All right. Now we're going to go on to the boat problem here. And we got Noah on a boat. I think that's funny. Noah's on a boat. Get it? Kicking it Old Testament. I'm going to go back to my distance, rate, and time problem. Distance, rate, and time. So if you want to know time, you do distance divided by rate. If you want to know rate, you do distance divided by time. Our question is going to be, we're going to calculate the speed of the river, and we know that it takes them the same amount of time. Okay, so it takes them the same amount of time. So time is equal. So time is distance divided by rate. So we're going to be doing distance divided by rate because it's all based on time. So there's two parts of this trip. There's upstream and downstream. So we got time, and I'll put a U there, time for upstream, and I'll put a time with a D here for downstream. So we got two different. Well, the time's the same. Okay, so let's read through the problem together. Noah likes to go for boat rides along the river with his family. In still water, the boat travels about 8 kilometers per hour. So in the river, it takes them the same amount of time to go upstream 5 kilometers as it does to go downstream 10 kilometers. So upstream is it's going to be 5 kilometers, okay? And the boat travels 8 kilometers per hour, but it's going against the water. So minus r would be saying taking speed away from going upstream. So your boat's going 8 miles per hour, but then against the water, you're losing rate. So it's going against you. Now when it's going with you, you go faster. If the speed of the river is r, right, an expression for the time it takes to travel 5 kilometers upstream, we just did that. Now you write the expression for going 10 kilometers downstream. So kind of mimic what I did here. So time upstream is distance divided by rate, and the river's water's working against you, right? So you write an equation for the time going downstream. All right, so the distance that you can go is 10, and then you do the speed of the boat that you go with the water. So with the water is adding, so that's what you should have. All right. Now, we want to figure out the speed of the river. So let me label this here. R is the speed or rate of the river. So you can do R for river or R for rate or whatever. So we want to know when this fraction equals this fraction. So now you see where the warm-up was related to, because we have equal fractions, we have proportions, so we're going to cross multiply. So I'm going to copy this to the other side where I have room. 5 over R, 5 over 8 minus R is equal to 10 over 8 plus R. All right. Now the number one thing with these fractions is you got to remember to put them in parentheses. It's Halloween season, so I guess I got doing brown and doing orange here. So we're going to cross multiply. This times this is equal to this times this. You can, either way you want to go, right? You cross multiply. So we do 5 times this, 5 times the parentheses, 8 plus R is equal to 10 times the parentheses 8 minus R. Then we can distribute. Boom, ba-boom, boom, ba-boom. Let's see if you can find R without me. Give it the old Harvard try. See if you can get R without me. So distribute. 5 times the 8 is 40 plus 5R is equal to 80 minus 10R. Then we got to get the R's to the same side of the equation. So I'm going to, I always say move the smaller amount of the variable. So negative 10 is smaller than 5 because it tends to keep things positive. Not all the time, but it tends to work better. So I'm going to add over, I'll switch colors, add over the 10R. Get that on the same side. So you can see the steps in orange, right? Distribute, get the variable on the same side, which is, made a mistake. Not 15, not 10. So you got 15R, the 40 drops down, and then the 80 drops down. Then we're going to move the 40. It's a positive 40, so we subtract 40. I'll do that in orange as well. So we get 15 times the rate is equal to 40. Then we got 15 times R, so we're going to divide by 15. So R is equal to 40 divided by 15. That is, when you divide on the calculator, 2 2/3 miles per hour, or 2.6 repeating miles per hour. So you divide that on the calculator, and that's what you get. All right, so that's how fast the stream is going. It's not a very fast stream, right? So rational functions are a polynomial divided by a polynomial. These are simple polynomials because it's just R plus 8. It's a very simple polynomial. But we can set the fractions equal to each other to solve these kinds of problems of distance, rate, and time. Okay, orange page. So here's another scenario. It's the same problem with the boat. So you can go the same time, right? So the same time, you can do 12 kilometers when you go with the water and only 4 kilometers against the water. I don't like the way they do this here. I like to do the cross multiply thing. So I would say 4 times 6 plus R is equal to 12 times 6 minus R. Then I would distribute. They made this harder than what it needs to be. Well, it's right there. Okay, so that step there is to me is very convoluted. So then you distribute, get the r's on the same side, and then divide, and you get r is 3. So it's the same kind of problem. Now you are ready for the orange page. But you're going to need some space here to do the orange page. So what you need to do is you're going to put number 1 right here. Put number 1 right here. So we're going to cross multiply. When we cross multiply, this is like over 1. So we're going to get this times this, x minus 1 times x plus 2. So cross multiply equals this. Okay, and then proceed from there. So you can do number 1 right there. Number 2 would probably fit up here. So again, you're going to cross multiply. So you're going to do 5 times 4 minus x is equal to 4 times 4 plus x. Then you distribute, 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 distribute. Okay. Then here, you're actually cross multiplying to show that this is equivalent to this. Purple page, review question, review question, review question. All right, here's the one that we did the other day. We're trying to raise the average. So you got to add x and you got to add x to raise it up to 400. So that's a good review question. All right.